Welcome back, everybody, to our next step in trigonometry. Today we're going to start talking about inverse trig functions. Now, you might see Sohcahtoa back up on the screen again. That's because Sohcahtoa is super duper important to trigonometry. Seriously, if you don't have Sohcahtoa down, trigonometry is going to be a tough subject for you, because in inverse functions, we're still going to need to identify what sine values, what cosine values, what tangent values from theta we're talking about. Okay, so quick reminder, Sohcahtoa, these are abbreviations of sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. And again, real quick, we're going to go through this just to make sure that we're all caught up to speed. So we're always going to put theta in one of the angles. It depends on the problem where they ask you to put theta. So for right now, we're just going to place it. And we're going to label our hypotenuse, remember, always across from our 90. Our adjacent side, again, helps to make the angle, and the opposite side is across from theta. So we're going to need to know Sohcahtoa, and we're going to be needing to know how to find those specific sides. Now, let's start talking about inverse functions. Inverse functions reverse a function, or reverse a particular function. An easy one to think about would be a function such as x plus 5, and the inverse would be x minus 5, right? They cancel each other out. So we denote inverse functions as having a little -1 exponent. What do I mean by that? Well, let's go back to Sohcahtoa real quick. When we're talking about inverse functions for sine, it's going to look like sine with a little -1 exponent. But sine's never going to change the ratio it's working with. It's always going to be O over H. Okay? Cosine, we're going to label as cosine inverse, and you're always going to have it written as A over H. Thanks again to Sohcahtoa. And lastly, tangent inverse is O over A. Now notice how I wrote these a little bit differently than before. Okay, that's because inverse trig functions find angle measures. You might remember that earlier, or last lesson, we had sine theta equaling opposite over hypotenuse. That's because we're assuming that we know an angle, and we're talking about side values, where now inverse functions, we're trying to find the angle. So O and H are the angles that we're trying to find, or this is the angle that we're looking for. Okay, we're going to be using these side values to figure out this angle, theta. Okay, same idea with cosine inverse. That's why our sides are inside the function rather than what the function's equal to, because we're trying to figure out that angle. Okay, so you'll notice it's the same idea with cosine and tangent. Okay, so super important. This, you really need to know the difference. Why? Because we're going to use two different functions on the calculators themselves. And if you don't use the inverse button, then you're not going to get the right answer, because the calculator doesn't know that you're looking for an angle rather than a side length. So you have to make sure to tell it. So we're going to have to make sure that we punch in the -1s. Now, we've done this in class. Again, I don't have a calculator here with me to put on screen to show you. So if you get to class and you need to see how it's done, please let me know. If not, I would suggest going on Google and looking up how to type that in to your calculator that you have to work with. Alright, let's start talking about some problems. Here we have a triangle already given out to us, and we have our angle that we're looking for, and they only gave us two side lengths. Now that's fine, because if you remember with Sohcahtoa, each of these functions only uses two sides. So what our job is to figure out which sides we're using, and then establish the function that we want to use. So what we're going to do is we're going to place theta at our angle. So here's theta. and we're going to label the sides from theta. So from theta, this is my hypotenuse, but I don't want to label it. I only want to label the two things they gave us. So that must make this the adjacent, and this must be the opposite. Now, why am I only labeling the two things they gave us? Because if I look, I have O and A, and when I think about Sohcahtoa, there's only one function that uses O and A, and that's tangent. Tangent is O over A. So I now know that the function I need to use involves tangent. But I'm trying to find an angle measure, so I'm going to be using tan inverse. All that needs to be done here is we're going to be substituting in the values again for O and A. So here it's going to be 27 over 38. This is what you're going to type into your calculators. Now, if you give me a second, I'm doing this on Google. I want to make sure that I'm in degree mode. I want to make sure that I'm doing the inverse, and I'm using tan. And we said 27 over 38. And we get a number out of 35.39. Now what's important for us to remember is that we're talking about angle measures. So our solution must include a degree sign. So our solution here is 35.39 degrees for this missing angle. Alright, so I have another problem. We're going to take steps through it again. We're going to put our theta at our angle, and we're going to again start labeling. This is my hypotenuse. It's always across from the 90, and this would have to be my opposite side. As you can see, my adjacent side is blank. And remember, I'm only going to label the two things that they gave me because I'm going to go back to Sohcahtoa and I'm going to look for the ones that involve an O and an H. Sine uses O and H, and those are the only things that we're given. So that's the function I'm going to use. But again, finding an angle measure, I want to use inverse. So sine inverse of O over H. Our O here is 40. Our H is 42. Now, don't worry about simplifying. I know that we can simplify. We don't need to worry about it. The calculator can handle that on their own. So let's clear out our calculators, and we're going to type in sine inverse of 40 divided by 42. And if we type it in correctly, which I did not, let's try that one more time. Sine inverse of 40 divided by 42 gives us 72.25. 72.25 degrees. Remember, we're talking about an angle, so we need to put in the degree mark. Alright, let's take a look at a different problem. This problem is for you to try, so please take a second to pause this video, try it out, resume when you're ready. Alright, let's check it out. I know that you're definitely marking everything that you're supposed to, so here's theta, here's our hypotenuse, here's our adjacent, alright, and we should remember Sohcahtoa. I'm going to really quickly write it up here. Sohcahtoa. Because now what I'm going to do is I'm going to look. I've been given A and H. I recognize A and H as being cosine. So I want to make sure that I'm using cosine inverse in order to find angle measures. And again, I'm just going to substitute in the values that we were given. Cosine inverse of 9 over 21. We punch that into our calculators. So we want cosine inverse of 9 divided by 21. And they tell us on the calculator that it's 64.62 degrees. Now, I was not very clear with specifying what decimal to round to, so just be careful that you read the directions. If they don't tell you, it's safe really to do any placement that you want, but you usually want to give at least 1 or 2 decimal places or a whole number. Here you'll notice that they ask us to round to the nearest whole. So they ask us to find measure of angle A and the measure of angle C to the nearest whole. So we get to choose, really, which angle we want to solve for first. It doesn't matter. If you like A better, solve for A first. If you like C better, solve for C first. I'm going to go with A. I'm going to mark theta. I'm going to mark the sides from theta. So here's my hypotenuse, and here's my adjacent. And looking at this, A and H is cosine, so I'm going to make sure that I'm using cosine inverse of 6/10. So let's check what that gives us on the calculator. We want cosine inverse of 6/10. And it tells us that that is 53.1. Nearest whole, I need to look at this decimal place. It's going to tell me that that 3 stays the same. So here we have 53 degrees, and that was the measure of angle A. Now, we're still looking for the measure of angle C. We could totally move theta over here and replace everything and do more trig. That's fine. You want to do it, go for it. But there's another way that we can do this too. We already know that this is 53 degrees. We just found it. And we know that this is 90 degrees. We already know also that there are 180 degrees inside of a triangle. So if we were to take 90 plus 53, which gives us 143, and we were to subtract it from 180, it's going to give us our final solution to this problem, 37 degrees, and that was measure of angle C. So just by doing a quick subtraction problem, we can get the second solution even faster. Okay, so could you use trig? Yeah, you can. Is that an easier way of doing it? Absolutely. Subtract the 2 given that you know from 180. That'll give you the third side, just like we've been doing all year. Alright, so here's the last type of problem that you're going to see for this video, and it's solving a triangle. Now, the only thing that I need to specify here is when you see the word solve the triangle, those words mean that we're looking for all 3 side lengths and all 3 angle measures. As you can see, I've written that out in the solution box. So we can actually go through right now and fill in some of these solutions without doing any work. Measure of angle Q is not given yet. Measure of angle R, however, is, and it's 90 degrees. And angle S is not given either. QR, right here, we already know is 7. RS, we already know is 24. We need to figure out QS. So these are the 3 things that we're looking for. Advice. My advice is that you find the angle measures first. Why, you might ask? Well, it's pretty simple. I want to find these angle measures, and I'm only going to use the values that I know are definitely correct. Let's just pretend that I came up with a number here, right? And let's say that it's wrong. Let's say that I got this number to be 3. Okay, if I start using these numbers, this wrong number in this side to find this angle measure, that angle measure is definitely going to be wrong too. So I suggest you find your angles first and use the side lengths that are given as well. And then at the end, use the side lengths to find out that last missing side. Okay, you don't have to. It's completely up to you what you want to do, but you know what? From my experience, it's a lot easier and keeps you a lot happier to not have to redo the problems. So I'm going to find angle Q first. I'm going to put theta. I'm going to label. They did not give me the hypotenuse. They gave me the adjacent, and they gave me the opposite, which means that I need to use tan inverse. And our opposite value is 24 over our adjacent value, which is 7. So we want to go to our calculators, and we want to be doing tan inverse of 24 divided by 7. And they tell us that that solution is 73.7. But remember, our instructions say round to the nearest whole, so we're talking about 74 degrees. So that was the measure of angle Q being 74 degrees. Now remember, we can use these two pieces to figure out this piece by adding them up and subtracting from 180. So 180 minus, well, 74 and 90 is 164. I subtract, that gives me 16. That's the measure of angle S, is 16 degrees. See how quickly we just found those two angles? Very quick, very easy. But now we got to figure out this missing side length. Well, we haven't discovered how to use trig to do that. However, if you remember, the Pythagorean theorem works really well. And because of doing all this trig, we already know which sides are our A side, our B side, and our C side. Our C side is always the hypotenuse. So that's the one that I'm trying to find right now, is the hypotenuse. So what I'm going to do is I'm going to do 7 squared plus 24 squared is going to equal x squared. 7 squared is 49. 24 squared is 576. If I add those together, we get a total of 625. And then to get rid of that square on my x, we have to take the root of both, which gives me x equaling 25. So QS is 25. Notice all of my angles have degree marks on them. My side lengths do not. If they gave me a measurement for the side lengths, we'd want to make sure that we put those measurements with it as well. So I have one final problem that I'm going to leave for you to try on your own. So take a second to try it, pause this video, and when you're ready to check your solutions, you can resume. Alright, let's see how you did with this problem. So here's our solution box. Let's fill in some of our solutions as we can. We don't know angle L. We know angle M to be 90. Angle N we're trying to figure out. MN, whoop, they didn't give us MN. LN they gave us as 13, and LM they gave us as 5. Now hopefully you remembered my suggestion of doing your angles first, because that's what I'm going to do first. Right? I'm going to find angle L. I'll put theta, and we'll mark, here's my hypotenuse. Here's my adjacent. Remember, it's making the angle. So I'm going to have to use, you guessed it, cosine inverse of 5 over 13. Our instructions say to round to the nearest whole. So let's go back to our calculator. Clear this out. We want to do cosine inverse of 5 over 13. 5 over 13. And they tell us 67.3, which rounds to plain old 67. That was angle L. To find angle N, we're going to do 180 minus these two together, which is 157. That leaves us with 23 degrees. Look how quick we were able to find those two. And last, we got to find this missing angle. Now, hopefully you recognize that this is your C value. So we've got 5 squared plus x squared equals 13 squared. 25 plus x squared equals 169. Subtract 25 away. Remember, we want to keep x by itself. That's going to give us 144. we take the root, and we find that length to be 12. That was mn. That's the solutions. Well, hopefully you did that one correct as well. And hopefully you're starting to get the idea of how important it is to remember Sohcahtoa, because it's the key to doing all of these problems. The rest of it is really just plugging in numbers into the right places. So if there's any questions you guys have about this, leave it on the website or bring them into class, and we'll do what we can to answer them for you. Alright, see ya at the next video.